Hello, in this video I want to go over my thought process of how I actually set and create overclock settings for my RX 570 and just my thought process behind how I troubleshoot rigs crashing and which settings to adjust. So in this particular video I'm just going to be using, this is basically if I want to set like an overclock preset in HiveOS, and I'm just going to be using this template and filling it out for overclocking the RX 570. And I'm just going to go and just show you basically how I set my settings. What I'm going to set an example voltage, where I'm going to start, what voltages to start with, and then what I will be tweaking. I will not be showing you live with an actual card and overclocking, unfortunately, because all my all my equipment is mining, and I don't have a test bench set up at the moment. But anyways, without further ado, I'm going to get into the video here. So for this particular example, we're going to be looking at if we want to mine Ethereum Classic or Ethereum on the RX 570 or 580 video card. So these overclocks will particularly be set for the RX 570 or 580. Now, they will work for the 400 series of cards, but this is mainly for the 500. Anyways, so for the core clock, I'm going to start with a very generic, maybe 1100 there, or maybe 1110 megahertz on the core. Core state, generally, I always leave this as 1. Most graphics cards, like the RX 570, for example, has different core states, and basically what that means is for example, in Windows, core state 1 would basically represent you idle on desktop, and by default, core state 7 would be, okay, you're playing a game max settings. But in this particular case, because we're going to be undervolting the card significantly, and 10 millivolts can be the difference between a card running stable or crashing, by us setting it onto core state 1, that means the first state that the video card will get its overclock applied to is the one that we're going to be running in, so there's less of a chance that it will crash. So of course I'm going to leave it as core state 1. You can put it to core state 5, 6, and 7, but I just found core state 1 worked best for me. Core voltage for the RX 570 cards, I found anything from 800 to 850 would run stable depending on the silicon quality. Now some cards could run 780, but that's not so important here. So let's say this is a brand new card. I've never run this. I don't know what kind of silicon quality it is. I have two options. I can either 1, start with 800 millivolts, or 2, because I don't know what kind of memory and what kind of memory performance we have, I'm just going to start with a safe setting of 850 millivolts. Then we have memory controller voltage as well as memory voltage. And these settings generally apply more to the Navi cards, but they do play an effect on the Polaris RX 570 GPU as well, but we'll get to that later. So for the memory clock, if, of course we haven't tested this GPU yet, I want to see can this handle 2000 megahertz on the memory clock there. And again, we have as well memory states. We either have 1 or 2. 2 is generally the kind of the last state for the memory, so you will be running at a higher memory voltage if you are running in mem state 2. So we're going to start off in mem state 2 because we don't know how good quality our memory actually is. Fan speed depends on what GPU you have. I'm probably going to start with like 50, or you could even start with 60%. And then once you get an idea of what your thermals are, you can always dial that back down. Power limit, not so important. And SoC frequency and voltage do not apply to the Polaris cards. To the AMD mem tweak here, you will be wanting to add a reference 20 or reference 30. So let's add a reference 20 as well as reference 30 depending on what kind of GPU we have. So let's say it is going to be a Alpida Samsung card, so we're going to add reference 20 there, and then we're going to test these settings out. Now by default these settings will return us about 28 to 29 to, no, this will give us about 29.9 to 30 mega hash on Ethereum Classic with these settings if it runs stable. If you are wondering, I do have a video on my channel showing with similar core clock and memory clock settings and what kind of hash rate you can get using the Team Red Miner. Okay. Now, let's say our card runs stable. What do we do from here? Now, we have two options. One, we can either deal with the memory state and try to undervolt that some more, or second, we can focus on the core clock and core voltage. I'm going to be focusing here on the core voltage because I find that is the easiest setting to move towards as a basically an isolated variable we can control. So 850 ran stable. To save time, I will just go to 830 millivolts, hit apply settings, of course, and reboot my system and see if that runs stable. Someone had a question in the YouTube comments: how long should you wait to know if your card runs stable? This really depends. It's all personal. For myself, I generally am not that patient, so I'll wait like 5-8 minutes. If it runs stable for 5 to 8 minutes, I'm going to go in there, tweak the settings again. So let's say it's been 5 to 8 minutes, ran stable. I'm going to lower this again to 820. If you want to be more careful, you can wait half an hour, and especially if you are dual mining Ethereum Classic or Ethereum plus Zilliqa using a pool like Ezil, sometimes when rebuilding the DAG, that is when your card is going to crash. And anyways, so now that you've been testing the card, you're able to lower the voltages some more. What happens when the card crashes? In this particular example, we're assuming that the memory clock seems to be running stable with memstate 2 and the 2000 memory set there. So let's say it crashes at 820 millivolts there. Well, then we can go back, increase it to 830, and then this next test after the crash, you are going to want to run it longer than those 5 to 8 minutes. So this is basically a good strategy of how I personally do it. First, when I first get the card, I'm going to test really aggressive settings. So I'm going to go through 850, I'm going to drop it to 830, maybe I'll even drop it to 800. But I'm going to, like, if it crashes, it's generally going to crash pretty quickly if the voltage is too low. So if it crashes at 800, so let's say, for example, 800, I'm going to restart my rig. And when your card does crash with too low of a voltage, either for a memory clock being unstable or a core clock being unstable due to too low of voltages, your system will freeze. So you will have to hard power down your system, and you'll know your system has crashed. Like if you have your monitor set up with HiveOS and stuff, you'll see it start to what I call dump. Just a whole bunch of white text gets put on screen, and it'll also show you what GPU has the issue. That's something else I can cover in another video, is how to overclock when you have multiple GPUs. I mean, it's the same process as that I'm talking about here, but you need to know which card you are adjusting. And generally, some of the mining softwares like Team Red Miner specifically, it will tell you which GPU has failed, but there's some other ways as well to kind of identify what card is actually causing the problem, so that you don't go about changing all the card settings. But that is also, again, why I do recommend starting with a higher voltage and working your way down. But anyways, back to the example here. We got 1110 megahertz on the core. Let's say it's running stable with 800 millivolts for core voltage. And now, like, let's say everything's running stable. What else can we do to optimize our GPU here? Now, the next thing after core voltage, and we're pretty certain that the core and stuff's running stable, we're going to focus on the memory. For the memory, even on the RX 570 Polaris cards, there are two voltage settings that we can kind of control. There's memory controller and memory voltage. For the RX 570, we can't actually control the memory voltage, but both of these input settings do affect I believe the power consumption of the card, and you can check that just doing inside of HiveOS. You just type AMD-info into the command prompt or whatever, and it'll show you all your overclock and voltage settings, and that'll give you an accurate idea of what your card is actually running at. Again, we can do that in another video. You can just request it in the comment section below. Alright, so in this particular case here, we are going to start with 850 millivolts for both of these voltage setting options. So for memory controller voltage and memory voltage, we're going to fill that out with 850. And again, for the RX 570, we can't actually control the memory voltage. We can only control the memory controller voltage, but I found we can input 850 into both of these areas available. Now, of course, you're going to want to restart your rig and then test the settings. Like, you don't always have to restart after applying the settings, but if it does crash, restart it, see if it runs stable. And if it does run stable for like an hour or two, or maybe the entire day, then you can come back in here, adjust memstate to 1. And yeah, actually that's the first thing you can do. Instead of, if you don't want to mess with these voltages here, you can come back in here, put memstate to 1, because again, memstate 2, that's going to use the higher voltage. Memstate 1 will use a lower memory controller voltage when running your memory clock here. So we're going to come back in here, set memstate 1, and then we can lower our memory controller voltage. We'll go from 850 down to 800. So right here is an example of a setting that I can generally run on majority of cards. I would say 60 to 70% of RX 570 cards that I've dealt with can handle these settings right here. Some cards will crash and I need to come back in and increase the core voltage. Some cards have a hard time maintaining a high memory clock, especially when you have the aggressive undervolting enabled as well. You're running like a low memory controller voltage here of 800 millivolts. It will crash. So that's where with some cards, in order to run 2000 megahertz on the memory, you can leave mem state 1, but come in here and manually adjust your memory controller voltage like so. And hopefully you can see that in the video. I forgot some of it does cut out. But anyways, yeah, again, in summary, the way I like to approach overclocking, start with a template. I have a couple templates on my YouTube channel. I have a template for the RX 570 for Ravencoin, a template of example settings there. Example settings for Ethereum Classic. These particular settings are for Ethereum Classic or Ethereum. As well, I do have an example setting for Ergo. And mainly what we covered in this video here is how I go about basically if a card crashes, I'm going to increase the core voltage if that's the one setting we're tuning with. Now, quickly, if the memory clock is an issue, like let's say we're back where we began, we have 850 millivolts on the core voltage there, but we're still crashing when we boost this up to 860, 870, 880. It's not going stable. That's where we're going to want to come back in here and lower our memory clock. If you want to be very safe, you can start with 1750 megahertz on the memory. We can get rid of these memory controller voltages because I only use them to undervolt the card a lot. So I'll say mem state 2, 1750 megahertz core clock if we suspect the memory is causing the issue. And the way we can suspect the memory is causing the issue is when we're increasing this core clock. When we're increasing the core voltage and we're not seeing any benefit, like we're going up to 930, nothing is running stable. So then what you can do is probably just leave it at like 900 just while we're testing to identify that, yes, the memory clock is the issue. So let's say we reboot the system again. It's running stable at 1750. You can go through that same process. You can bump up the clock a bit, 1860. Does it run stable? Okay, then we can reboot the system. We can try new settings, 1940. Also, a good way to see if your overclock settings are stable or not is if you get any incorrect shares. If you get incorrect shares, that generally means either your core voltage is a little bit too low or your memory clock is a little bit too high. As well, you can adjust your memory controller voltage as well. So let's say mem state, let's just say we're getting incorrect shares with 800 millivolts on both memory voltage as well as memory controller voltage. Then we can also come back in here and increase that to 850 and test that again. There are a lot of settings. I wish I could just tell you do this and it's going to work 100% of the time, but unfortunately, as most of you guys know, if you have multiple cards, like not all cards are the same, and some cards, yes, they can overclock really well on the memory. Some can handle 2000 megahertz with mem state 1 with as low as 800 millivolts. This is hard to type. I got a laptop here. Anyways, like some cards can run this no problem, where you've got even like 790. Like this is a good quality card right here. If you can run 11, 10, 790, 800 for memory controller, 800 for memory controller as well, and mem state 1. But not all cards are going to be like this, and that's where when you're overclocking, again, you can go back to the beginning of the video. We started with a high core voltage, made sure everything ran stable, and then we started to reduce core voltage. And if core voltage wasn't the issue, like let's say it crashed and we kept increasing the core voltage, then we knew, okay, we're moving over to troubleshoot the memory side of this card here. And the way we troubleshoot the memory side of the card, first, immediately drop it down to 1750 megahertz, see if that runs stable. If that runs stable, then we can start increasing the frequency to find, okay, what frequency is stable and we can have a good undervolt with. But anyways, that's pretty much going to wrap up how I set overclocks for the RX 570. I hope this gives someone a little bit of insight, also a little bit more confidence to actually play around, go through the process of undervolting your GPU, getting a feel for, okay, this GPU here, it's got good silicon quality. It can run at 800 millivolts for our given core clock there. Okay, I also have a not so good card where the memory this is also a good note. Like, let's say the GPU needs 830 millivolts to run at 1110 megahertz core, but our memory can't overclock any higher than, let's say, 1860 megahertz. That'll mean we're not going to get 30 megahash out of the GPU. And there's a really quick way to calculate this out if you don't before you even test the card out in like Team Red Miner. So I opened up a simple calculator here, and if you've watched any of my other videos, I know this is a long one, but stick with me, I got some good stuff here to share. In most of all my overclock videos, pretty much I always say, with whatever algorithm you're mining, it's always a ratio between core clock and memory clock that gives you the mega hash, like an efficient mega hash number. So what we can do in order to figure out what our core clock setting needs to be if we want an efficient core clock for this given memory clock, what we can do is work backwards. Let's say we needed 2000 megahertz memory to get 30 megahash. So what I'm going to do is divide that by 30 megahash here, so 2000 megahertz divided by 30, and that says approximately that we need 66 megahertz on the memory clock to get 1 megahash equivalent. So that means if we divide, what am I doing here? 1860 divided by 66 megahertz, 0.6 of course, we'll do just 2.7, that means we're going to be getting about 27 to 28 megahash with this memory clock, or that's what that memory clock is capable of doing with, of course, the proper memory timings. And yeah, I'm not going to repeat myself there, but you can go back in the video. This is an important point here. So now, in order to figure out what core clock we need, we know that to get 30 megahash, we need about, let's say, 1100 to 1110 megahertz core. I personally start to feel like 1110 megahertz core is kind of the sweet spot. So I'm going to, again, divide that by the 30 megahash that we get with these settings. Okay, so it says we need 37 core clock in order to get 1 megahash. So what we do is we take... All right, what are we doing here? We're going to take 37. We're going to multiply that by 28 because that's what the memory clock is able to output in terms of megahash. So we're taking 37 megahertz on the core clock, and we're going to multiply that 28 times because that's 28 megahash. And that means we only need to run 1040 megahertz on the core. I'm going to repeat that again because this is very, this can save you a lot of power on your GPU, especially if you can't overclock your memory well. What we do is we're going to find out, I'm going to do this math one more time. We're going to find out what our first, what our memory clock is able to output in megahash if we had the right core clock. So in this case here, we know 1860 megahertz memory clock will give us about 28 megahash. So we know that it takes about 37 megahertz on the core per megahash. So what I'm going to do is I'm going to multiply the 1 megahash number of core clocks, so that's 37 in this case, by 28 megahash. And we're going to get our optimal core clock. And the optimal core clock basically means it's not too low, bottlenecking the memory clock, and it's not too high, using too much power. So in this case here, I'm going to come here with those accurate numbers we just got. I'm going to enter them in, and of course, as soon as you lower the core clock, you're most likely going to be able to lower your core voltage, saving you even more power. Your GPU is going to run cooler, and it's going to be thanking you in the long run. Anyways, this was a long video. Hopefully you took something away from it. In summary, again, when you are overclocking, setting your clocks for your card, in this particular case, I was talking about the RX 570, but whatever GPU you have, remember, it's a process. First, I like to start with core voltage, leave the memory as close to stock as possible. Once we've got our core dialed in somewhat, like, okay, let's say we're aiming for that 30 megahash again, we do 1110 core at like 850 millivolts, which is a very, it's plenty of millivolts generally to run stable there. Then we troubleshoot, okay, if it works, lower core voltage. If it doesn't, increase core voltage. Retry. If once we increase the core voltage a certain amount, then we start to move over to the memory clock and figure out, is my memory clock too high? Do I need to bump my memory controller voltage up by going into mem state 2 and manually increasing my memory controller voltage here? And just playing around with the settings to figure out, okay, what is actually causing the card to run stable? And no, it's probably like, yes, for most cards you can probably figure these settings out pretty easily, but you're going to have some cards eventually that give you just such a pain in the neck to figure out how, like, what clocks are actually going to run stable on them, and it will take you a lot of time to figure out. But all I wanted to share in this video is you got a couple variables. You got core clock, core voltage, memory clock, mem state, as well as your two memory controller voltages, which are pretty much the same thing as far as I'm concerned. I don't know too much about how they affect it, but I do know they are related to mem state, and you can kind of override the mem state voltage. But anyways, I'm going to wrap the video up there. Thanks so much for your attention. Hopefully you took away something from this. Definitely drop a comment down below if you want a more in-depth video on any of these settings here. And yeah, remember, core clock, core voltage, core clock, memory clock. It's always a ratio for whatever algorithm you have. Ravencoin has its own ratio, Ergo has its own ratio, and that's where you use the calculator, you do some simple math, you divide your core clock by the mega hash you're getting, you figure out what kind of, anyways, I'm going to wrap the video up. That's enough talking. Thanks so much for your attention. If you have any questions, feel free to drop them in the comment section below. Goodbye.